In this video, we'll illustrate how to make a class, when we're going to define the class linear, which will hold a linear equation and have methods that help us work with that linear equation. So the first thing we need to do is when we make an instance of the class linear, we'll need to save the values that we need associated with that linear equation. So in this case, it's going to be y equals mx plus b. So there's a special name for a function that's called when we initialize an instance of a linear class, and it's called init with those two underscores. And we have to it'll end up being passed the name, so we might call it my line or whatever. And then we also have to pass it the information that we need to save. We want y equals mx plus b, so we need an m and a b. And so the first thing we're going to do is we're going to store that information in the variable self.m. So we're going to store m in self.m, and we're going to store b in self.b. This associates the m and the b that we passed in here with the data that's going to be stored in with the line object that we make, the line instance. Let's set up something else that it can do something. Let's have it make a method which has value. And when we want value, that means we're going to give it an x value. It's going to plug into y equals mx plus b and give back a y. So we need an x as a parameter here. And we're going to return and we're going to return mx plus b. So I'm not going to put m times x because in this function we don't have access to this, but we do have access to the m that's been stored with that object. So we need self.m times x, but x is something that is passed, and that is not intrinsic to the line. It's just a new x that we're going to give it, mx plus, and then self dot b, which is going to pull out the b from the object. That's it. We now have a class. Let's make a test here, and let's call it my line, and we'll make an instance of the linear class, and we have to give it the m and the b. So the m, let's just say 2x plus 3. Okay, so now my line has been initialized, or as soon as I run, it'll be initialized. And now we can have access to the methods. So my line.value, let's actually print this. Hold on a second here. Okay, so we're going to print this, my line.value, and we have to pass it the value. Let's plug in, I don't know, something easy like 10. So it can be 2 times 10 plus 3, so it should be 23 when it prints. Let's see if this program works. And it printed 23. So this works. Let's make another function. We could do the same thing we do with the quadratic and have it go the other way around and call solve. But I'm not going to do that now. Let me just not finish writing that. And let me show you another one that's we used before. The two that I use mostly, there are lots of different ones of these special little functions, methods, and one is called str. And not def. We're going to, anytime you print the linear equation, the instance that you made, it'll either just print something, who knows what, but or it'll print whatever is here. So we're going to have it return a string that it could use anytime it goes inside a print statement. So let's do the mx. Well, again, this should be self m, so it's going to pull out the right m. So m x plus, and again, I'm not going to have b here. I'm going to have self.b. Okay, so it's building a string to make it look like the way I want it to look. So, oops, I never printed it. let's actually print my line. And I'm not even going to do anything fancy about it. There it is, 2x plus 3. Actually, let's make it look like a function. And f of x equals 2x plus 3. So this is the bare bones class. You initialize things here, like this. And now let's use this class just to show you the types of things we can do. If I want to make a whole bunch of lines, I could make, let me do a list comprehension. I'll make a list full of lines, okay? And I'm going to have, let's say, okay, so let me do this. Let me return, let me have the list be a list of instances of the linear class. So I'm going to make lots of objects with lots of different m's and b's in it, okay? Let me just make it, just for simplicity, let's make it with lots of different slopes. Let's have the y-intercept for all of these be 0. Okay, so what I'm going to do is for b in range, and let's have it start with the slope of 0, and let's go up to, I don't know, a slope of 10. So I'm going to have 10 different lines here. Okay, so here's how it works. This is going from 0 to 10. Actually, oh no, I'm glad I looked at this. My m, I want slopes to go from 0 to 10, and this is going to return a list that'll have an instance of the linear, first time with the slope of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then stop. So we can now then loop over this for line in lines, and let's just print each one of these out. Okay, and let's see how it looks. So this made a slope of 0, 1, 2, 3, 4, 5, etc. And we now have a list. Let me print lines so you can see what it looks like. And lines is a list of objects. So right now this doesn't show the pretty lines. It just shows lines, but let me leave it at that because it's showing the list, and the list shows okay, I didn't want to do this. Maybe I'll do this. There's a second little function here. Let's see if this works. I'm 100% sure this will work. Yeah. When you're displaying something for the user, you use str. When you're displaying something for a programmer, like when you print a list, it's showing the brackets and all the stuff that a programmer might care about. It uses this function. So this is actually showing us, it's using the nicer way to display the line, even when it shows a list, instead of just showing the list object. I'm sorry, the linear object. Okay, so really powerful. This to me is pretty clean way of handling lots of pretty complicated stuff.